start, we understood that you can use linear regression in statistics as well as in predictive modeling. The question is, how do you know if your predictive model is an accurate model? How do you evaluate it? And when do you decide that this model is not good enough and maybe you need to change it to a different model? There are plenty of machine learning algorithms that you can use to come up with a better solution. And what the meaning of better solution? So must be their measurement to evaluate those models. So let us start with a case study. And this case study is about predicting if a patient will have second heart attack or not. I provided you a copy of this document, which will walk you step by step with RapidMiner on how you can do this case scenario on your own. However, I'm going to walk you through it in this tutorial. Also, if any one of you is interested in knowing how to do the same case with R, so I have the code, I run this with R as well. If you are interested, just shoot me an email and I will send you the code, and so you will have solution also in R. Okay, so let us first understand what kind of data do we have here. So let me lower this one here, and this will be after a little bit. We're going to discuss those measurements. So our data, start a new one. Our data consists of two data sets. One is a training data set, and the other one is a scoring data set, which is again is testing also. So this is the term testing or scoring. Testing comes from the predictive model aspect, that you are testing a model on a new data set, where scoring is if you are a businessman and you have data about your new customers and you want to score this data on a predictive model you created before to predict what they're going to do in future, what kind of purchases they're going to make. And so you are scoring this data on a model. Okay, so let me convert this table just to make sure to understand what kind of attributes do we have here. So this data consists of the following. We have the age as one attribute, or one variable, or one independent variable. We have marital status, and the marital status here, it ranges from 0 to 3, where 0 is single or never married, 1 is married, 2 divorced or separated, and 3 is widow. Gender, 0 is for female and 1 for male. Weight category, we have 3 levels here. 0 if you are normal weight, you're perfect with your weight, and 1 overweight, and 2 obese. Cholesterol level, this is a continuous numerical number and ranges from 122 to 239, and that's a value of the cholesterol level tested. Maybe so each one of those is one patient, so assume that this is the last doctor visit, this is the numbers from having a blood test, and that was the cholesterol level for that patient number 1. Stress management, this is a course that assumes this data is your organization data, and your organization started to run some type of stress management course, and encouraging employees who are really stressed to attend that course to teach them how to manage their stress. 1 if the person attended the course, 0 if he did not. The treating anxiety, again, this is a measurement based on the evaluation of those doctors for the last visit, and it ranged from 35 to 80. The higher, the worse. Okay. Second heart attack. So this data is about patient who had first heart attack, and during their last visit to their doctor, their information were filled in their forms, and some of them had second heart attack recently, and some of them they did not. Okay, so let us see in general how many patients do we have here. So let me scroll down. Okay, so we have 139, take the header off. So we have 138 total number of patients in this data. Okay, and out of those, let's see how many of them that they got second heart attack. So let us visualize it afterwards. It's easier in RapidMiner. Also, you can do the visualization here in Excel, but since you're going to use RapidMiner, that will be handy to see how you can visualize the data. So this is our data. This is our current data of patients. Okay, so this is the training data. This is the data we're going to create a model to predict our Y, and the Y here is our second heart attack. So this is our response or our dependent variable. Yes, it's awful. Okay, so let's do it. Go back. So this is our dependent variable, which depend on all the other variables which we have here, about 8. 1, 2, 3, 4, 5, 6. Sorry, 7, and the 8 is a dependent variable. So you have x1, x2, x3, x4, 5, 6, 7, and you're creating the Y, the linear model, based on the information here. So what the predictive model is doing here, looking at the patterns of those values, and accordingly creating the response value of this model. So it's knowing, okay, what the values of those cholesterol, what kind of pattern I can see in the cholesterol level to decide if a person will have second heart attack or not. Okay, so that's our training data. The same for our testing data or scoring data here. So let me open that. Okay, so the second data, as you can see the differences here, that we do not have a response, and we have more patients actually here. Okay, so which is really good. So we're gonna have so this is our second data. So this is our scoring or testing data. Let me maximize it a little bit. And the idea is, like we did in our previous case, is to create from this model, to create a model from this data, from the patterns observed in this data, and then get this data applied to this model and predict, and those are patients who had first heart attack and none of them had second heart attack yet, to predict what the value of the second heart attack in this new data. That's the whole idea. To know what is the value of the of those new patients or the patients who did not experience second heart attack yet, and try to prevent it. So if imagine this data being used by a health organization like Blue Cross Anthem. So they are trying to lower the level of surgery their patients or their customers have by monitoring their numbers, monitoring their treatment, monitoring their health, and trying to advise them maybe to do some stress management courses, because they notice benefit of stress. So, but first we have to prove if they really benefit of did those patients here who took the stress management benefited from from it and didn't have second heart attack? Okay, and how many of them? So do we have a really good argument? The cholesterol, if those who were having a treatment for their cholesterol level and taking some medications, and their chances now are less, so that could be another way to convince the other patients who have high cholesterol to do some type of regimen treatment to lower their level. Okay, so that's the goal. And of course, we're going to have the last case of rapid minor would be a business case in which we're going to predict the marketing campaign of company, and we're going to evaluate it as well. And that would be more the assignment that you're going to work on. Okay, so let us start with this data, since now we know what the plan is. Now, I did not mention to you before, but if you notice, rapid minor comes with a lot of operators, and by the end of this portion of the course rapid minor, I'm gonna list a complete site for training to become an analyst, complete video tutorials for free actually by rapid minor, and you can get the certificate over there, and also a lot of resources that if you're interested in this subject to continue. So also I have to mention here that you have data access to many different type of data. It doesn't have to be Excel. So technically rapid minor can read CSV, SPSS, Stata data, SAS data, Access data, you name it. It can work also on cloud-based data, so you can connect to Azure, you can connect to Power BI, you can connect to any to Oracle data and SQL, MySQL, or even Microsoft SQL Server. So it provides you with all this, so you can look at all these connections. I use some of them even to Amazon AWS, and also to Google Cloud Storage. What else I have to mention here? That there is a complete set, yeah, that's important. There is a complete set inside rapid minor. It's called the training resources. So after you are done with this course, what you can do actually, you can look at the data available. So you are interested in some, let's say, the credit scoring, so you have data here for the credit scoring to use. However, also you have the models related to it. So our work with predictive modeling is considered as supervised learning models. So here we have linear regression, so you want to start from that. So here we have hotel application linear regression model. This is a telecommunication company, also a complete model over here. So if you open those resources, we'll tell you step by step by what to do. What else? The community, this is important because I'm proud of my students who really managed actually to be. So if you downloaded Rapid Minor, you will see that the project they did with me are listed over here. So you can see some of the projects our student did. For example, let's say here we have the churn propensity modeling. Okay, so the moment you open the project, you have the data and you have actually the actual model. With WKU on it, so you can go to this the poster competition and the name of the student who did it. So if you click here, technically you go to the website at Western and you see the poster he did, and if you run it, it's working completely. So that's amazing. And we're gonna discuss this chart today. So that's how really you can learn more by just looking at all the resources available for you from here. Beside that, I want to yeah, it has all the operators if you're interested in Python. The samples, yeah, that's the one I want to talk about. The samples. So you have tutorials here. You can start from the basic to the end, even with the Hadoop and with the artificial intelligence hub that they created. So you start one by one, and the tutorial is very nice because it walks you through. It tells you what to do. Okay, welcome. Bring a data called Titanic data. So you open here and you bring the Titanic data, you drag it and drop it. Okay, and now it's telling you what to do. So let us run this to see the data. Okay, run anyway. You have to link it, sorry. Okay, so that's what we learned. And now you run, you see the data. So it's a really good way to understand the whole. It's the much easier way to learn actually, and you have plenty of modules over there. Okay, so that's for the heads up. Let us start our project. So I'm gonna open here. I'm gonna either I'm gonna stay in the model, or I'm gonna create a new repository for those who forgot how it is. So I'm gonna create a new repository. You don't have to. You can put all your work in one repository, but it's good also to organize yourself based on the project. So I'm gonna name it second heart attack. Okay, so I don't want this place. I'm telling it I want to use a specific location on my computer, and I called it heart attack case study. Okay, so this is where, or maybe I'm gonna put it inside the data set. Okay, that's it. So I'm gonna finish. I'm gonna create a new, so you just click on the blank process, and no, I'm not gonna save the tutorial. And this is our blank where we start our process, and double check that if we have it. When you start getting a lot of projects, you will start not knowing where you are. So I'm gonna click here. I'm gonna say store process here, and this is my process, the second heart attack process. Okay, so here it is. This is the one with double cylinders. So this is my project now. I'm gonna import data. Recently I noticed RapidMiner started to put those inside, but I still prefer to bring the data inside, or teach you. Maybe you can use the read operator today. So if you have different data, all you have to do is just, since this is XLSX, which is Excel, so I'm gonna just read the operator using the reading operator. I'm gonna need two. So this is gonna be the training, and I'm gonna click here. So this is the operator. You have to select it. Make sure you selected it, and then click on import. And from there, last directory where I put my process in, and that's it. It's here. So I'm gonna bring the training. And this is my data. Let us double check this is the one that has the response, the Y. Make sure all of those, and since the data is numerical, here are integer, the weight, all of them integer. However, the second heart attack, you make sure if it's not on your end as a polynomial selected, you have to change it, because here we have two cases, yes, no, if the person gonna have second heart attack or not. And the typical model you would use is logistic regression, and I created the video for logistic regression for this case, so you can watch it as well. We'll remind you what logistic regression is with association to this case study, a very short video. Okay, so from here you have to change if on your end you don't see it as polynomial. And the meaning of polynomial, just you can pick, of course, binomial will be the same results. Polynomial means more than two categories, so it really doesn't matter if you picked it as polynomial or binomial. Okay, most importantly, it should be polynomial, which means category. This is a categorical data. This is two stages. So typically with linear regression, as I mentioned in the previous video, you would use it to predict, let's say, the house sale price, which is a linear regression model based on multiple characteristics. Or I also mentioned the predicting after the medical status of a patient after 6 months from now. So also the medical status is also would be a response of linear regression model. However, if you are trying to find a two state, if someone is going to default on paying his credit card, that's yes no situation. And here's where the probabilistic model kick in, which is you have the probability, I mean, from 0 to 1, and you have a threshold. So if you decide 0.5 is a threshold, so everything bigger than 0.5, which means high risk, so those are the people who might default. And if you have a higher threshold, maybe 0.7, I bet banks, they use 0.5 is not less to be sure that the person is going to pay his loan. Okay, so again here, so we have categorical type of information or data. So that's our first Excel file. Running the data, let me just hide this operator, because you get an error if you are using our operator and not linking it to the result. So you right click and you just disable it by clicking on enable, uncheck the enable. So now this is our training data, and from here let me look at the statistics. All the variables, all our axes are integer, and this is polynomial, so we are fine. We're gonna look at the ranges in a second. So let us bring the second data now. So let me enable the operator and link it here. And now I have to configure it, tell it which one. That's the scoring data. Okay, everything is integer, so we are fine so far as data type, but we are not sure as a range type, because you have to have both in the same range. So let us run it. Now you have two data, and you can see you are confused now which one is which. So that's a good idea now to give some annotation to our work. Right click on the operator and let us rename this one. This is the training, and this is the scoring or testing. Okay, so now if you run it, at least you can distinguish which one is which. Okay, so for the training data, I can switch those. For the training data, you have about 138 patient, and for the scoring data, you have about 690 patients. And that's typical. That's always typical, that you create a model on a smaller data set, and when you apply the model, you are applying to a bigger set. That's in any location you are familiar with. One of those locations that we highly likely all of us visited, Best Buy. So Best Buy has the software for credit, customer credits, in which has a predictive model about the chances of anyone coming to the store and applying for credit card to default or not. So when you go there and they ask you, can you, I would like to apply for a credit, they let you fill a form, and then they tell you go browse the store and come back like in 5-10 minutes. All they are doing, they are entering your data into this predictive model, and that predictive model is scoring your information. This time is not a data set, it's one entry, so you are one entry. You're scoring that entry into the predictive model they have, which they generated from maybe thousands of customers, and they look at your score that comes back and the chances of you to default or not. Okay, so that's very similar here. And usually they are scoring those on hundred thousands of customers, whereas the model was created maybe based on 20, 30,000 customers. And the better the model, the more accurate recency has. That means if they keep updating the model um, from the beginning with a huge data set and periodically, you will have more accurate model because things change. Okay, I'm gonna save my process. I'm gonna go back here. Or let us first, yeah, that's good now to do this. Let us look at the data. That's what typically you do. You see the data. Now we know the information, what it is, and what we want, we care about seeing the distribution of this data. And that's more statistically. In our case, in data mining, all we care about is not to have missing data, number one. Number two, not to have a lot of outliers, and typically we don't care about if it's normally distributed or not. We don't care if it's skewed to the left or right, you know, so it's not normally distributed. We don't care if what else. I'm talking about the axis, not the y. I'm gonna give you some rules for y. If you're gonna create a model on the y, and then what we're gonna score on it should be the same ranges. So for example here, this is the age. So the range this model is gonna gonna provide is from 42 to 81. Now if my new data has a value of 39, then I will have a problem. And what usually you do, either you are you try to bring it to the minimum, you know, just as a solution, and there are some solutions to those cases. So, and there are models that you don't need to apply the ranges, like decision tree, naive bayes, what else, ensemble models, neural network, all those models that you hear about in machine learning. They don't care about the ranges and about even missing data. Decision tree easily can handle this missing data. Okay, so we looked at those. What I care about the most here is my respond. Okay, I'm not gonna look at those. I'm gonna look more about how many patient I have. I'm gonna open the visualization, would be better. How many patient I have that they had second heart attack. So this is the testing data that I'm gonna create a model of. So I have from the year 68 patient who had second heart attack, whereas I have 70 who did not have second heart attack. And that's a good model. Why? Usually when you want to create a predictive model, you always have to try to have a balanced data of your respond. Like you need, if you are having a categorical values of two values, categorical variable of two values, like in our case here, you have to have them very close to each other. You cannot create a good model where this data I have only, let's say I have 10 patients who had second heart attack, and here I have 70. And the solution for that would be to balance the data. This is a concept called balancing the data. So technically what you're going to do, you're going to get rid of 70 of those and create a model only based on equal, closely equal y variable. Okay, so that's it. What else? Something else to mention. So this is the scoring data. And again, that's a concept. We're going to create a scoring data, and then we're going to evaluate in this video. So let us go back. Now that we know, I'm going to hide this temporary because this is the last stage, and you know, the concept I'm going to cover today, you do not need even a scoring data to evaluate your model. So there is a technique, a splitting technique called in predictive modeling that we're gonna use. So let us do what we usually do. We have to tell that our y set the role, and you can do it from outside. I didn't show you how you can do it from outside. Let me do this quickly. let's say I'm reading data, the same data, just to show you how you can import this data. And at the same time, you can set. So when you are here, instead of using set role, you can change the role, and from here you can, if you don't see the pop-up, just click the screen and it will show up. You can change it from here, so when it comes in, it comes automatically knowing that this is your prediction. Okay, so if I say that and I run, you see automatically knows that this is the prediction. This is your Y, sorry, this is your respond. I'm gonna delete it. The same, just I'm gonna follow what we did before. So this is the set role, make sure it's connected, and the same. So I want to show you that there are a lot of aspects that you can use in future. I'm not going to teach you those, but those are really important. We are using the label, pay attention, not the prediction. And this is the attribute that's going to be the Y. So we're telling it that this is our Y. Now we're going to create a model. And before creating, so if I follow what we did last class, I put the model immediately. Now I'm not doing that. What I'm doing is the following. And I have to bring you some document, and it's going to be in Blackboard. How to evaluate a predictive model or classifier, because here what we are doing, we are classifying if a person is going to have or not have second heart attack. Technically, in data mining, the idea of evaluating a model is based on splitting the model. And what meaning splitting the model is not the model per se, splitting the data in the model. So when you get a data and you want to create a model, sometimes actually you don't even have a scoring data. So imagine the following: you got data of your I don't know, okay, so let's say in your organization you give loans to employees, and you have this data about all the employees who applied for loans, the amount they took, and the payment over the last period, the last couple of years per month distributed. And you want to create a predictive model that you can predict if someone is not going to pay in next month or not. Okay, not pay the due payment, monthly due payment. So you can create a predictive model based on the data on hand by dividing this data into two data sets. And those two data sets, one of them you're going to use it to create a model, and the second part you're going to use it to test that model, and that will be your way of evaluating that model. Now, how it's done is not simply as I said. It uses a random number generator to pick those cases from your data. Let me explain a little bit more. So assume the following. So this is the data set that we had. So this is our data set. So based on this data, what I'm saying that RapidMiner is going to randomly create, split this data into, let's say I'm telling him split it 50-50. So it's going to randomly pick data 1 set and data 2 set. Let's say it kept first patient in data set 1. Then patient number 2, consider it, this goes into the data set 2. This is gonna stay in 1, 1, 1. This one's gonna go to data 2. Randomly, using the random number generator. Those 3 ended up in data 2, etc. So this is what it does. It's gonna create all those, it's gonna split those into 2 different data sets. And you decide how much the split is, how much you're gonna use for your training model, and how much you're gonna use to test that model. So typically what we do, we use 2/3 of the data to the training if you have a small data set. So if I don't have like 10,000 or 100,000 or million of records, then I don't have enough data to create a real good model. So that's why I will be lenient to give more cases to the model to understand the data. So I will give it 2/3 of the data. So if you had, let's say, 1,000 patient, I will give 700 to the training and 300 for testing the model. And when I'm testing the model, as I said, let's say the green ones, those are the ones gonna be in the testing. The value of the response is gonna be deleted in those when the model is tested. So they will not be part of it, otherwise would be considered cheating. So you create a model based on the first data portion, the 2/3, you have a model. You get this data left, apply to the model. Now the model is gonna give you the predicted value, and at the same time, remember, those are not really deleted, you have them in your system. RapidMiner will bring them back and show them to you and will tell you, here is the value that the model gave you for that patient. So if give me yes here, it's okay, model, it's good. If give me no here, it's good. The model is good, it's accurate. Then if it gave me yes here and yes and no, that's terrible. So 2 out of 5 cases, only the model scored accurately with the result. So I don't have a really good model, and that's the way you evaluate models in data mining, in predictive modeling. Okay, so that's the idea, and let me close now. Don't save. So here's the logic. So there are many different splits. You decide based on trial and error. That's the logic. You tune until you find the best model. So you might split 80-20, you might split 70-30, 60-40, or 50-50. It depends actually on how big the data. If you have much big data, I never split 50-50. I will split 60-40, training 60 and 40 for the testing. Now, if you go deeper with data mining, you can split into 3 data sets. So you create 1 training, 1 testing, and 1 you validate again if the model is good enough. So, but in our this short course, we're gonna do only two data sets: 1 to train model and the other 1 to test the model on it. Okay. Now, RapidMiner, instead of using the percent, is using the ratio of 1. SAS actually it uses the percent, and SPSS modeler uses the percent. So in RapidMiner, so instead of putting 80-20, you're gonna put 0.8 and 0.2. So it's not that difficult. So what we're gonna do, we're gonna create a logistic model, and we're gonna try to see how accurate this model is. So let us continue now. Okay, so the operator responsible for doing this is called split data. Pay attention because there are some other splits if you downloaded some other extensions. So that's the one. You link it, and after you link it, you just make sure you selected it. You click on the edit the parameter, and from here you have the ratio. You select an entry, and you select first the training data, how much you want, 0.7. It doesn't matter if you put the 0 or not, it's gonna understand it. And the second one, 0.3. So I'm giving 70% of my data to training and 30% for testing. And if you recall, we looked at our data, and our data was about 138 cases. Okay, as you recall, we had 138 patients in the testing data. So those gonna be split, and we're gonna see the split in a second. So if I link this to the results, see automatically I'm gonna get another outside, and I have a third one also. But since our data only split into 2 portions, I only have 2 portions here. Okay. Otherwise, if I put in the enumerator another entry here, so if I put this 2, and here I use the third one for evaluation, then you can use the 3 results. In our case, we are not doing that. Okay, so we're gonna run this. You can see now, because we set the role, this one become green, and we can see that we have two data sets. One of them has 41 examples, patients, and the other one has 97. So you can guess that the first one is used for training, the two-third of our data almost, and the second one, the 41, the one-third, is used for the testing or scoring. We're gonna use for the testing or scoring. Now you can pay attention to what if you want to see really did RapidMiner did a good split in your data. So you can look at the statistics and look at the second heart attack label. As you can see, it split it really in a very good way. It gave you in the first data set, the training data set, 48 of those are yes, patient had second heart attack, and the no, you had about 49. So very balanced outcome. So not only randomly picked, but also it balanced the why of those cases that been picked in those cases, in those data sets. And let's see again if it did the same. You can assume the same, because actually here it's yeah, that's it. So it picked for the no, the same. So it picked did the same balanced data, 21 for the no and 20 for the yes for the testing data. That's good actually. So now we don't have to worry about the concept of splitting those accurately. So I'm gonna close those, and all I have to do now is what we did in the previous class, but from one operator I'm gonna generate. One's gonna do the model and train the model, and then the second one we're gonna apply the model. So this is the logistic regression model. I'm gonna bring the logistic here. I'm gonna attach it, okay, and we are gonna create a model from this data. Select it over here. Let me run, and it created a model for us. This model, again, this is a logistic model based on the probability. So this is the model. Now we're gonna apply this model on the testing data. So we're gonna use apply. Okay, so let's bring apply model, and so this is our model. So historically, or in previous lectures we selected the scoring or testing to enable. We applied the model. Now we are selecting the testing, those 41 observations that we saw RapidMiner generating, splitting from the original data, and you can see them, and we applying the model to them. So this output from here, so this is a big data that we had 138, 97 went there, and 41 went there, and we're applying the model to it. And let's see the label, and let's see the model. We care more about the label now, not actually the model. So I'm gonna delete the model, a little bit, just shortly, so we can explain what's going on here. So let us run. So here's the output, also similar to what we saw before. So this is our output here, and we should see here that this model actually okay, so this is our model, and those are, yeah, now I can move. Okay, so this is the actual and again the model is showing you the result on the testing data, the scoring data. The 41 examples, like if you remember, if you recall, we had 21 of them no, heart attack, and we had 20 with heart attack. That's what the actual data. So let's see how well this model did the logistic regression. So take a look, compare each patient. So those are accurate, as you can see. Keep moving. Here, the model misclassified. The actual patient had no second heart attack. However, this predictive model found out that yes, is gonna have heart attack, and with high, very, very high. So this guy is really at high risk. Almost 99% confidence that this person is going to have second heart attack. Okay, continue. Now, and this is another mistake here. Now, it's not logic to browse the data visually. Of course, there is a metric to give us those results. And not only that, usually in a real life situation, if you are Best Buy manager and you are trying to score and evaluate a model, or you are the developer, programmer of their model, you're not gonna look at 100,000 millions of customers and see how the model did. So most likely there is a better way for that, and we're gonna do that in a second. So at least now we know how the data is. If you want to see the percentages this model come up with, even that it made mistakes, so it brought us almost, not almost, actually opposite. So here it predicted, this is the actual, we had no 21, it predicted 20 of them not to have heart, almost cross results. Okay. So how we can evaluate this model? So there is what is called the performance of a model. We're gonna bring what is called the performance, as I said. And we have different types of performance based on the operation you're doing. This is a classification problem. So I'm gonna bring the performance for the classification. And what else? Let me bring it here. And I'm gonna run, what I care about the most is the accuracy of this model or the classification error. So let us start with the accuracy. I want to see how accurate this model is, okay? And all you have to link is this label that the model labeled, and the performance is gonna be calculated. I'm generating. And here is the overall performance of this model. So the model in hand is really having a really huge accuracy, about 92.68, almost 93% accuracy. This is a huge, it's a big number. So let us go back to your statistics. So if you recall, when you have two categories and you are trying to decide yes, no, remember it's like flipping a coin, so the chances when you flip a coin to be accurate or to get one of the faces is 50%. So if you go back when we used to evaluate our model, we would say we are really happy if we come up with a model that is more accurate than random sampling, more accurate than 50%. So whenever you get, even in data mining, a model that is higher than 50%, you are happy. So if you recall, or if you heard of Netflix competition in data mining and knowledge discovery conference a couple of years ago, they and that would be a decade ago actually. So what they did, they gave the data of the recommendation of their customers, and they wanted people to compete to improve their model. And actually the team that and I was part of the students in University of Global working with their data at that time. So they gave $1 million for the best model, and we were able to come up with a model that about 67.39, where our competitor, the team who won the competition, there were about hundreds of teams joined in that competition. Their model was about 69 I don't remember the complete figure, but less than 70, and that was amazing, enhancement to the Netflix previous model. So when you are talking about the accuracy, 92, this is a perfect model. And how can you evaluate this model? You look at it in this way. So, and since with COVID-19 now, you hear a lot about, true positive, false positive, and false negative, all those terms. So all those terms come from here. So true yes and true no. So the true yes is those patient that yes had heart attack. So this column here represent those patients who really had heart attack. Okay, in the original variable in the data, not the model. This is the origin. So those are the columns. If you look on the columns vertically, those are the actual value. So 20 patients had second heart attack, and 21 didn't. So the sum of those. Now look at them horizontally. This is what the model produced. This is the yeses of the model, and this is the no of the model. The model, as we said, and we saw that told us there are 21 patients that had second heart attack. Out of those, 19, they're exactly the same that they were in the original data. Okay, so the model was able to predict those who had second heart attack. 19 out of 20. So only missed one patient. Okay, so almost you are saying 19 over 20, and that's what's come 95% accuracy. And those two that the model added that thought they will have second heart attack, their status was no. So only it missed those two and consider them as no. Now I will not really worry about those two. If I told them you're gonna have second heart attack, so you better work on your diet and on your cholesterol level, that will be no problem. I will be more worried about that one that the model missed. If I had 0 here, I would be super happy. I will, no matter what the value here, if this was 0 for this case, this is the health case scenario. Now if you are in marketing campaign, you will see that the result has different interpretation, where you would like more to get those people who will gonna really buy your products after sending the campaign. You care about those to detect them more than the one to lose them. Okay, now the model in the scenario of no, the model predicted the actual true. So this is the crossing of those two lines, the horizontal and the vertical. 19, they were really having the status not having second heart attack, and also the model say they're not gonna have second heart attack, which is good. But actually in the real data we had 21. So the accuracy of this part is 19 over 21. That's why you get this number 90. Those numbers here represent class recall. The term is called recall, which means how many, the recall is how many out of the total the model was able to bring. And the precision is the sum of those over the value of the yes. Give you an example that will stuck with you, so you will remember the differences between recall and precision. Search engine Google. Imagine that you have a website with your name, and this website has 20 pages, and in those 20 pages your name listed in all those pages. Okay, let's say 100. Okay, let's say 100 pages. You listed your name, and you wanted to see if Google will find your pages if you googled your name. So you googled your name there, and you found out that out of those 100 pages, Google only presented 80. Okay, however, Google brought about 500, which is the rest are wrong. Okay, so from other pages, people with the same name. So the 80% of your pages appeared on Google search. Those are called the recall. How much the search engine was able to recall the information you wanted to find. Now, about the precision, how much accurate that model, Google search engine was in finding those pages. So out of those, let's say it brought 1,000 pages and only 80 of those were actually yours. So 80 over 1,000, which means 8% the precision of Google. Because really it did really bad bringing all those other pages, but it's gonna do it anyway. So this is the differences. The recall, you're searching for something and you are looking at it, how out of those really the model was able to bring. The precision, out of the total the model found, how much is really accurate that should be found in each category. So hopefully will stuck with you and you will remember those types. Now, so let me go a little bit now into the meaning of all these. So I'm gonna share this document I made that will explain those information in details and in much easier way for you. Okay, and I think here what I did with that model, see the values are different, so highly likely I split them. The example I'm documenting here, and you can do the same. The split was different, so I might use 80 20, and let me see, just I'm gonna make the case so you can understand when you run it. If you see those numbers, yeah, those are the numbers that I used in the document. 80-20%. 80% of the data went to the training data and 20 to the testing data. We have a small data, so typically you do that. There's no right or wrong answer for how much you're gonna split. As long as you get good model, you stop here. So if you do that, you notice that this model is really very accurate in finding. So when you change the split to 80-20, the model will not miss at all. So 100% recall of all those patients that they were having second heart attack. The model found all of them. The model added another 2 to those, so consider them they can have second heart attack. And here the percentage, the total is 14 for not having second heart attack, and the model gave you 12 out of them. Okay, 12, consider them as found the 12 and add on top of them 2. Okay, so no difference, exactly the same, just you follow those, and so you can understand in details each one of those values, the meaning of recall, how you calculate the recall, and how you calculate the precision. And I'm gonna ask you to do some other type of models and to find me those results, and at the end to tell me which one really performed the best. Okay, so what does that mean? Because then let me go back here. Now, in typical scenario, if you are now, I'm happy with this model, and if you recall what we did in last class, I don't need this performance. We didn't have that, and we didn't have that one either. So let me disenable this just to show you what we did last class. So this is our data. We took the data to logistic regression, and this is a new data. We built the model. We are happy with this model. It's 100% accurate to detect the people having heart attack. Now you can score this data that I showed you that had 690 patients. So that's the new data. I cannot tell if accurate or not. We use the more, those people didn't have yet second heart attack, okay? So, but the model is telling you the chances of having second heart attack is the following. So from this model, this data found out 350 people gonna have second heart attack and 340 will not, and those are the percentages, almost the fraction, 50%, 50%. Okay, now what else you can understand from the model? So I'm not gonna use this, I'm just showing you what we did historically, and that's typically, so I'm not gonna use this data. I want to complete with the other models and how you can decide afterward, if you have different models, how to pick among them. The process I'm showing you here is really slow, that you are going to do it step by step, you know. So highly likely there's a better way, and yes, of course there is a better way. So let me bring back what we did. Okay, so if you following the news, you know, you hear about his performance. If you want the accuracy, you might also, so let me look at the classification error, how many mistakes it makes, and see if I can bring some other. So those are many different parameters that you can use if you're familiar from the statistics and you want to look at the values over here. You might consider them. The squared correlation that we typically use in statistics to evaluate how well the model is capable of capturing the variation in the model, but that's sufficient for now. Okay, you can change some parameters in the model if you want different than what was default. You can read about those actually in the help. Let's see the help. Okay, I'm not gonna, so typically you click on this model, you should be able to see the help section. Okay, let me see the view. Let me, okay, the results, I can see the show panel. Usually when you mess up this interface, you can click on restore default view, is bringing you everything. So that's why this one was disappeared. I closed it sometimes. So you can click on logistic and now understand all those parameters that maybe you want to learn more about them, and that's in the future. You can do that if you're interested. So if you want to look at the solver, what kind of algorithm is using, you can follow those steps, and you can also jump to the tutorial immediately and all those values here. So for example, if you jump to the tutorial, what's going to do is going to open a completely new tutorial over here instead of this, and you can work on it. Okay, so now the question is, maybe there's a better model than logistic regression, and how can I tell? So there is a way to decide that. Also, before going further, the step-by-step I told you about is the following. So let me open. Okay, so when you follow the step-by-step, I want you just to see how this model can also interpret the status of those patients. So when you generated the model, okay, so after we generated the model, the logistic regression model, Try to look at those entries that they decided to have them as yes and no, and you will notice that there is a pattern in those entries. So I picked those two here. So look at that patient number 95 and this patient here number 554. The first one, the model told me that it's not going to have second heart attack, whereas the the first one, the second, and this guy 554 said it's going to have. They have a lot of similarity, both of them the same age, see 70 and 70, the same marital status 3 and 3, both of them 0, which means female, and the category weight, the first one that didn't have heart attack is 0, which means has a normal weight, where the second one is overweight, and the cholesterol level of the first one is a normal cholesterol level 188, where this one has high cholesterol 236, and the first one attended a stress management course, and this one who the model predicted to have did not. So you can see the trends here. So if I am a health insurance agent, and I'm looking at this data, I would say, yeah, there are some evidence here, and I will look at the research in this area, and I'll say, okay, so let us do some type of collect the data about only those that high at risk, and let have a course for them, or try to convince them for free to attend a management stress course, or how to lower or the impact of high cholesterol on having second heart attack. So that's what I wanted you also to see. By data mining, you see patterns in data, and that's really important. Okay, and you will have that available for you. So let us now talk about if I want different model. And as you notice, we don't need to be an expert in the models. If we can browse around, and then we can learn about those models. So for example, decision tree is one of the popular models because it's super easy. So I'm going to use it instead of the logistic and see if the model is better. All I have to bear in mind that the logistic regression gave me an accuracy, and which is I care about, 92.86%. Okay, and more importantly that this value here of the true yes, positive yes, is 100%. So let's see another model is going to do the same or better. I'm going to right click on this model, and from here I'm going to change the operator. So I'm going to replace the operator, go to modeling and prediction, and then you're going to go to trees, decision tree. Okay, I'm gonna pick the normal one, decision tree. Okay, that's it. That's all I'm doing, nothing else. I'm gonna run the model now. Okay, the model actually gave me exactly the same accuracy, the same number. However, as you can see here, the model was less accurate in the positive yes. So let us now find out how we can decide between different models in an easier way. Okay, I am gonna disconnect a couple of things over here. I'm gonna leave the part that you apply and evaluate the performance of a model, and the part that you split the data and you build a decision tree model alone. So if you think about what we have been doing, we brought the data, we decided what is our response variable or response predictor, the y, and here what we did, we split the model into two parts, part training and part testing, and here we are evaluating the model. So technically, if you think about it, those are two parts. Those are the major two parts in creating a predictive model. The right side, as if, is the one that is gonna evaluate whatever kind of models we are using in this area. So if I have multiple model, I should be able to find some way to help me deciding which of those models is the best. So there is what is called the ROC, and I will give you more theory about it in a document. So I'm going to use what is called the ROC comparable chart model. And the idea is you are going to use the ROC function to help you decide which model is the best model. So let me bring this theory a little bit here. This is the short one, but also I'm going to give you documentation with details to read it. So yeah, it works like following. So if you bring a training data set and you want to decide, because this is where the model building is happening, you want to decide which one among those logistic regression, decision tree, neural network, and you can put many more as long as they work on this data, specific data. The ROC is going to do the following. It's going to compare among all those models, and it's going to visualize for you which model is the best. Now, what the meaning of visualizing? So first of all, the ROC chart or curve is the abbreviation to what is called receiver operator characteristics. The name historical has goes back in the centuries, so a little bit is confusing. It was used in the signal detection to show the trade-off between hit rate and false alarm rate over noisy channel. So it's been used in World War II. So its historical meaning goes to the to the not even to the existence of the computer. So it's long time ago, and all it does, it measures the trade-off that you have, and that's what we are doing here. We're trying to find the trade-off between the true positive, so the y-axis is the true positive, the model that can predict, and the x-axis is your false positive. So if you recall, in our model, we wanted the number of patients that really had second heart attack. Those are the true positive to be detected. Okay, so the true positive to be correctly detected and not be missed, and not be considered as false positive. Okay, so here we go. So this is a very simple model. What this model did, this model was able to predict the first patient, for example. It's any case, the first patient, the first circle, the blue one, from the beginning of the model was able to predict correctly that it is a true positive. The second is always also is correct. The third patient also was correct. The fourth patient was correct. However, the fifth patient in the row of this data, just imagine Excel file, and I'm checking every row in this Excel file. When we reach the 1, 2, 3, 4, the fifth patient, the model disclassified that patient. So instead of true positive, it gave it false positive. So that's why you see this change in the horizontal line. Now, after that, the model with the next row was predicting it correctly, okay, and because it's going in the vertical line, and the following was correctly, and then actually all the data was stabilized in the correct manner. Okay, so which means that the performance of that specific model wasn't 100%. So you would love to have a model that will predict all the cases 100%. So you would have a model would have a shape like this, and that doesn't exist. This is when you get 100% accuracy of model. Okay, it would be like this. So typically you want a model that goes as maximum of, so the more cases that been predicted as true positive, especially if you are sorting them from the beginning. Okay, also there is another naming for that, the gain function, but we're gonna focus only on the ROC function. So this is how it looks. A model, this smoothing of the model, this is how it works. It's got, if you have like 100 of cases, so you go in zigzagging way. So if you are going straight, that means you predicted correctly. Any deviation in the vertical line on the runs, it's a wrong classification. Okay, so that's just the explanation how it looks, and we're gonna use it just to decide which model is better, so visually easier for us. And imagine you have 100,000 of variables, and this model is gonna just plant out for you the results instead of looking at the data visually. Now there are the trade-off if you have if you have a small data set. So usually you focus on this type of model that is start at the beginning, really with the good results of positive, of a true positive, and then maybe deviate a little bit. Okay, whereas when you have a large data set, even if your starting is not so big, but you are maximizing afterward, that means your model is good. Okay, so that's a trade-off between the type of visual chart to pick if you have big data. And here we're gonna talk about 100,000 millions of record about big data. Okay, so this is the case that you gonna study as your assignment for the marketing campaign, but I'm gonna use it here just to show you how they look in RapidMiner. So here, like 3 models were examined. You have the decision tree, you have logistic regression, and the random forest. And according to this data, you can tell that the blue RSC for the decision tree is the best model for that specific case scenario. Okay, that's the whole idea. Another concept, the lift chart, we're gonna talk about it after we try the following. Okay, so let us now, so as you can see here with your data, so let me bring this data over here, keep the split, and enter the training data set inside the comparing the model. I'm gonna copy that, or I'm gonna cut it actually. I'm gonna go inside the ROC and gonna paste it. This is one model. Okay, I'm gonna add another model from here, which was our logistic regression. Okay, and I might bring naive Bayes model. Some of them will not work based on the data. We have categorical data here, so we'll see the one that they work will decide accordingly. Okay, this is one, this is the second, and this is the third. As you can see, I am inside the process, so all you have to do is to click on the process. So here's our comparison. Now we're gonna see we are not actually applying the model at all over here. All we are trying now to predict is the differences in between those models on that specific data. So I'm gonna hide those since I'm not gonna use them at the time being. Okay, so let us see. So you're gonna take the link from the second output connector, the blue line, and let us run it now and see what kind of results we have. So here we go. It was very quick. And as you can see here, the decision tree really outperformed the logistic regression and naive Bayes. Now, based on our case, you might decide to stick with the logistic regression only because it worked better with the sample we have. but that doesn't guarantee it's gonna work better when you are using it on the 690 cases that we don't have the response value. So usually you have to trust the ROC chart to accordingly to decide. So if I'm looking at this result and I see that big difference, I would pick the decision tree for sure. Okay, so that should be your model that you're going to apply the new data, the scoring data that you don't have a value for the second heart attack in it. Okay, so that's the portion of how you decide which model is the best. So we decided it is decision tree, so let me remove that. Now, how about the concept of using the performance to decide how the model is working over time, which means if I want to decide to do some type of cutoff, what kind of cutoff I should do. So now in the time being, let me finish this case and start applying the second concept on the marketing campaign data, which will make more sense for you to understand what the meaning of the cutoff and percentage of the data. In this case, we have second heart attack case scenario. It's a health case. You want to save all of them. You really don't you worry about all the patients, not just 10% of your patient to save them from second heart attack. And you will understand why I'm saying this shortly. So to finish this case, we say, okay, we have to bring the decision tree. That's the best fit. And in this case, so this is our data over here. Now you have to bring the scoring, because this is the data that let me delete this one, bring it as operator from here. This is the data. So I want to bring the scoring data. Those are the new patients, making sure okay, everything's okay. So this is our data. Let me now connect it to our apply model. This is our model, and this is the end label, and I want now the model to give me the labeled data and their chances. Okay, so if you run the model, so that should be the model that you're gonna give this health insurance agent. Imagine you are the programmer or the analyst hired to give them the predicting the second heart attack of those patients based on that first data, and accordingly you want to sort those with the highest risk. So you might decide to get this data out of RapidMiner to Excel and look at and sort them and decide how to deal with it. Okay, so let me show you how you can get the data out of here. So this is our labeled data. You can easily, like you saw the read, I have the write. So I can write in Excel technically. So instead of just watching the model here, I can, that label I can import actually to Excel operator, and you're gonna use the second output, not the first one. Will allow me to save it in a location I know where it's gonna be saved. So I'm gonna open the folder, last location. Yes, yeah, keep it here in that folder that I'm using. We give it a meaningful name, scored patients at risk of second heart attack. That's it. That's good. I'm gonna save that. Run, you have to run to be able to get the result out. So this result gonna be saved. So now if I minimize RapidMiner, you should see that inside the data set you have a new data over here. It's called the scored patients at risk of second heart attack. Let us open it, and it's gonna open it in Excel. So this is what the predictive model does. So let me arrange it. data has a label, yes. Okay, so what do we see here? As you can see, beside the information we had previously, those are the old information we had from the original data. But now, beside that, we have a percentage at risk, okay, with how much confidence. So let me search for those that the model was 1% confidence, like 100%, which means as a ratio here, that they're gonna have heart attack. Those are the one that I'm gonna pull their information, give it to the agent, the health care agent, that she's gonna contact them and try to work with them for a better, health style to prevent a second heart attack. So that's it for this data. That will be the result that usually that you benefit from using a predictive model. Next case, we will look at the business model for marketing campaign. That's it.